So a lot of you guys had questions on number one, obviously, for assignment one, and that's what we're going to start with. Unit 12 packet, assignment one. That one didn't have any math. That one was straight conceptual, talking about these masses on a spring and how they move. And so number one, I completely get why we have questions about it. I tried to put as many of those questions as I also could in the practice quiz that you should be doing on Quiz and the mini test that you should be finishing up by midnight tomorrow. So that being said, I wanted to talk about how that mass on a spring is actually really similar to a pendulum, and we've already done it. So I commandeered my little dry erase board thing because she's napping; she doesn't need it. So the idea behind these guys are these two different systems, the pendulum system and the mass on the end of the spring system, are both, the main idea is that they both follow Hooke's law, and can be described through simple harmonic motion. Simple harmonic motion is just any motion that repeats itself due to some exterior force causing, restoring force causing that object to repeat its motion. In the case of our pendulum, it's gravity and tension on the string from our reading notes that cause that mass to begin to swing down. As it swings through its equilibrium position, it comes back up the other side, runs out of energy. We talked about that in our unit 9 when we talked about energy back in February and January. It runs out of energy because it stores all that kinetic energy as potential energy and then comes back. And so I wanted to talk about, in this case, where you had your potential energy at a maximum and kinetic energy at 0 up here, like we talked about way back in February with that unit. As it swings through, you're going to have the fastest possible velocity. The velocity is going to be at a maximum. Your kinetic energy is going to be at a maximum, and you're going to be completely out of potential energy at this particular equilibrium position because it can't fall any further. It can't gain any more of that energy or any of that momentum from gravity that was pulling it down to that equilibrium position in the first place. From here, it begins to lose that potential and kinetic energy and come all the way back up. So I wanted to bring that up because the springs do the exact same thing. If I have a super compressed spring down here and I allow this mass to move, it's going to move outward in this particular direction until it reaches its equilibrium position. And once it reaches that equilibrium position, it will still have some momentum. It will still be moving, but the spring won't be applying any more force to it. So as the spring presses and applies that force to this mass until it reaches the equilibrium position, the object's momentum will continue moving it to the other end, where it will again reach this point where it runs out of kinetic energy, it runs out of potential energy, and the spring has now been stretched and wants to come back to equilibrium, and it will. And so that's how the mass on the end of the spring winds up doing its simple harmonic motion. Two different kinds of forces, one spring, energy from a spring, and the other one being from gravity, but they both accomplish the same thing.